Hi, and welcome to a lecture in the series of lectures on C Sharp programming. This particular lecture will look at design, and as always, it's presented by myself, Dr. Peter O'Neill. Okay, so creation. Different people go about this in different ways. I do it like this. Here I am, sat there thinking, and all of a sudden, the idea comes into my head. And straight away, my mind starts to think, how am I going to code this? Just like a little light bulb. Now, there are many considerable numbers of different methods. There's top-down, pseudocode, or Program Design Language, PDL, bottom-up, event-driven programming, XP, which is extreme programming, and these just describe a few of them, and there are a few more in the course book. Here I'm only going to take a look at 2 or 3. So let's look at the top-down method. Here is an example of a top-down design. We break tasks into subtasks. Where a subtask is large, we break it into other subtasks, and these subtasks up into other subtasks, and so on. Each subtask will become probably a method. Take the game Noughts and Crosses. So it's human versus human. So top down. First of all, we may start with a board as simple as just 1 to 9, laid out in the arrangement. Each of these numbers may be a button, and the task of changing the GUI to a nought or an X will be part of their event. Pseudocode, Program Design Language, PDL, and Structured English are all the same thing, really. They are a mixture of programming languages and good English, or shall I put it this way, clear English. They have no standard. We just make it clear by indenting and by using no ambiguous or as least ambiguous statements as possible. We start with a high level, like this. Still noughts and crosses, remember. Version 1. Human number 1 goes. 1 question mark. Human 2 goes. 1 question mark. Keep repeating this until one's 1. That's it. That's all we need. That's a very high level version. In other words, very little description. Version 2. We're now going into a deeper and it's getting closer to the coding level. Still quite a way away. While game not over, in other words, while not won, right? Get person 1 move. Get person 2 move. End while. So we're going round the loop and each person gets a turn. Notice it's getting closer to a method call in C Sharp. Version 3, even closer. While game not over, notice now we've now got a method called game not over. Get person 1 move, get person 2 move. And notice now we've also got our sub methods. So here we'll call in one and then call in the other one and so on. So now we're getting sub methods as well. Okay, but there's something missing this. There could be also a draw. So we're checking for win, but we're not checking for draw, which of course in noughts and crosses is most probably going to be the outcome if the players are equal to each other. We need to check if the game is over, e.g. not only if it's a win, but if it's a draw after each player has played. So let's move back to our PDL version. We can put enhancement, what if draw. So here's our enhancement. While game not over, which has now become a flag in a way, right? Get person move, game over, right? Get person 2 move, game over, end while, display winner or draw message, game over. So we're actually putting a flag on it and it will drop out at that point. It's the message box here that says what it will do. But again, it's still quite a way away. So we can also have other things like, what if move is illegal? In other words, if I've already selected that box, I can't select it again. So we could create a procedure called check move. We could call this procedure from within our other procedures or methods. So get person move also now checks move before it changes it. We can also at this point, if we wish to, we could also say check to see if the winner or a draw. So now it's becoming just 1 player play, 2 player play, and actually all the things that happen in each player happen within each player. It's called from that player. Okay? And we can do the same again, of course, on get player 2 move. So here's our check move. And check move in itself could, as I say, we don't have to have it called from here, the winner or draw. We could have it called from within check move. So we could say check the move. It validates that it is a move. Then it's to see if you've drawn. Then it sees if you've won. And then it comes back to here. And same on both of them methods. Notice how the methods are becoming more focused, e.g. top down. Now here's an idea. We've basically got a routine if we look at it, because as I said, once we've put our check move that becomes to check to see if we've drawn or if we are the winner, then actually all we've got is we've got a game loop at the top, which has our game program, which then loops through person 1 and goes to check move, and then comes back up and goes to person 2 and checks move. And that's all it does, essentially. And of course, it terminates in check move if the person's won or it's drawn. So that's called a structured chart for the game. So, if I gave you the previous diagram and nothing else, here's all you could tell me. It has 4 methods. Game called person 1, person 2, move, and person 1 and person 2 move, both called check move. Let us take this design a step further. Place game over with an if. Okay, so let's think about the status of the game. It can be a draw, human 1 wins, human 2 wins. It's still running, and they are our basic states of the game. Now, let's look at the pseudocode. So, game running is now a flag, basically probably a boolean, and it says while game running. So while game is running, it's true, good. Get person 1 move, check status. Now check status might be things like, it might be a method which returns the value of game. So it says turns game to see if game's running. So it can change the status of game from running to draw to win. Yeah. Now only if it's running and not over does it get person 2 and their status. And if it else's it ends the move ends game. Move ends game. And then right at the bottom we've got display the winner. So you can see how this language has been developed slowly, and we would have procedures. Normally we'll put numbers down the side so that when we call a method, for example get person move, we might put a number in front of that and have a method call that number with get person move, so we know it goes down to that method. So each of these lines constitutes a class and or method. Prototyping. In the good old days, we say that laughingly, this was a type of interface. There you are, look. That was my interface. The little underscore next to the end of shoe used to flash on and off. That was it. And from that you had to build everything. You had to write everything out. So if I wanted to create a button, I would have to draw the button, and then I'd have to put that data into a structure, which meant that I could quickly look at that structure and say, is my mouse within that rectangle? And if it is, then that button has been called, and therefore make an event to receive that button's call. Gratefully, you'll be happy to know, and you do know, that with the development of Windows and with Visual Basic and then C#, applications of that sort of graphics on them now. They don't have to do any of that. You can just drag and drop. So C# is one of the best prototyping developments because of its tools. You can just drag and drop and create a development style very, very quickly, which is brilliant for prototyping. In days gone by, for me just to make a button, I'd have to sit down and write the entire code, which may take me over a week. Today, you put a button on within a couple of seconds. Take the noughts and crosses again. The interface can go through many changes until the customer is happy with it. So this is often called rapid application development. Okay. So here is our rapid application development. Notice it's still doing the top down, and we have press a key number to change it. Yeah, and it says computer's turn. Well, we'd never do that. It'd be player 1 or player 2. Okay, because we're getting into AI then, and at this level we don't want to do that. Then we could change the interface to say whose it is. So notice now it's got a title, OXO game. It's got whose turn it is, and now we've got proper buttons. And you can see that the X is being played and O is being played, and X is to play next. Then of course we can add colours to it. And we can ask our users all the time, what do you like about, well, I don't like this and I don't like that. Can we have this? Can we have that? And you can of course develop that. Right, so that gives you a very quick overview of design. There is quite a lot more of information held in the chapter within the actual course book. If you have any questions at all, please feel free to email me or speak with me during your tutorial session. Thank you for your time.